Good morning, guys. Am I audible to all of you?
Good morning, sir. Yes.
Okay. So today we are going to discuss two more design patterns. One is decorator design pattern and another one is bridge design pattern. And from tomorrow onwards, every design pattern I am going to give you two different kind of examples so that you can easily understand. So let's start with the decorator design pattern. First, we will discuss what is decorator design pattern. Then we will discuss how to implement the decorator design pattern. Then we will discuss the class diagram. And after then, we will discuss another decorator design pattern real-time example. So let us start discussing by discussing what is decorator design pattern. According to Gangov definition, the decorator design pattern allows us to dynamically add a new functionality to an existing object without altering or modifying its structure. What it means? It means you have already one existing object. Let's say some object called XYZ. And this XYZ object having some function. Function means let's say function one is there and function one doing some operations. Now you want to alter that operation, right? Alter that operation means what? You need to add some kind of additional functionality, but you don't want to you don't want to alter the existing object. You do not have access to that. You can consider you do not have access to that class. You cannot inherit that class, right? Those kind of things are available. Then how you are going to do this? Right? So for that purpose, you need to use decorator design pattern. Let's assume that you are creating one pizza. So plain pizza is there. Then after the plain pizza, you want to add some kind of additional things, right? Additional things means you want chicken pizza, you want vegetable pizza. That means what? Top of the plain pizza, you want to add something extra, something additional. Then, but you don't want to alter the plain pizza. Whatever the plain pizza produces, that is going to be same. After then, I want to add some kind of additional functionality, but I don't want to change or alter the existing plain pizza. In that case, you need to use decorator design pattern. So decorator design pattern actually act as a wrapper or over the existing class. That means the decorator design pattern dynamically changes the functionality of an object, right? And it will change the functionality of an object only at runtime without impacting the existing functionality of the object, right? Whatever the existing object keep, uh, that will be there as it is top over the existing object, it is going to add some additional functionality. Who is going to add the additional functionality? The decorator design pattern. How it is going to add the additional functionality? That we will discuss. But further now, you just remember that decorator is nothing but it is an object which is going to add additional functionality to another object, right? Let us understand this first with one example. Say, let's assume that you are having one class. Let's say you are having the circle class. And let's assume that you are having this draw method within the circle method. And assume that this draw method is just going to draw a circle. Then if you want to consume this draw method, then what do you need to do? First of all, you need to create an object of the circle of class. Once you have the circle object, then you can call the draw method. Once you call the draw method, then it is going to draw a circle. Now, what is your requirement? You want to, yes, I'm going to draw a circle, but what is my requirement? Now I'm going to give a color to the circle. But what is the problem? The problem is I cannot change this circle class. I cannot change this draw method, right? That means I cannot modify this existing object. But I want to add some additional functionality. And what is that additional functionality? Once the circle is drawn, then I have to provide a color. I want to color that circle. How I can achieve this? I can achieve this very easily by using decorator design pattern. So what I need to do is I need to introduce the circle decorator. It's a class. Don't think that the same circle class. It's a different class. And this circle decorator, what is the role of this circle decorator class is it is going to decorate this draw method or it is going to decorate the circle object with color. So what I need to do inside the circle decorator class, right? So if you look at these two classes, the signature is going to be almost same. This is the circle object having the draw method. This is circle decorator object having the draw method. But what inside the circle decorator draw method is, inside this draw method, first of all, you need to call this draw method, right? So First of all, you need to call this draw method, which draw method circle object draw method. And then once the circle object draw method is called, means what happened? Means the object means the circle object is created. The circle is created. Once the circle is created, then I need to set the color, right? So if you look at this diagram, right? This is the circle decorator object having the draw method. From inside the draw method, first of all, I need to call the draw method of the circle object. Once the circle object draw method execution is completed, then I will set the color of the circle object. This is how the decorator design pattern is implemented. So this is one new object, you can say new class, whose responsibility is to add additional functionality to one existing class or existing object. So in this case, so in this way, without changing or altering the existing circle object, I can provide additional functionality by using the circle decorator object. And this is nothing but your decorator design. Let us understand this with one real-time example. Suppose if you know how a automobile industries work. Now in automobile industry, so first of all they will produce the car. But if you know today, the car is having two types of engine. One is car with petrol engine, a car with diesel engine. But apart from that engine, everything is going to be same. Whatever model you are going to buy, the model is going to be same for petrol engine, as well as the model is going to be same for the diesel engine. That means the body, the structure is going to be same for both the car, right? Both petrol engine as well as the diesel engine. Let's assume that this is the car engine, car without engine, and this is my existing object. This is my car without engine. This is my existing object. Now, what is my requirement? Now, as per the client requirement, I am going to add either the petrol engine to this existing car or the diesel engine to this existing car. But I cannot change or alter this car. Then how I can do this? For that purpose, I'm going to use decorator design pattern. What I need to introduce? I need to introduce one object called car decorator. You can consider this is the car decorator class. This car decorator class will accept this car without engine, and then based on the requirement of the client, he either need to add the petrol engine or he needs to add the diesel engine. How it is going to add? Now see, in while we are going to implement this car decorator, it is going to be an abstract class. This is a concrete class. This is our actual, this is our object, existing object. This is going to an abstract class. This abstract class is going to be extended in two different classes. One is car with petrol engine. Another one is car with diesel engine. Now, if the client want the diesel engine, then we need to create an instance of this class, right? Instance of this car with the diesel engine class, and to this instance I need to pass this car engine. Then this class will take the responsibility to add a diesel engine to the car and return the car to the client. Now if the client want the car with the petrol engine, then we need to create an instance of this car. First of all, you need to create the instance of car without engine. Once you create the instance, then the client want the car with petrol engine, then you need to create an instance of this car with petrol engine class, and to the constructor of this class you need to pass the existing object which you want to decorate. And in that case, this car without engine, it is the existing object. To the constructor of this class, we need to pass this object. And then what this class constructor is going to do, it is going to initialize, and the draw method is also there. That draw method is going to call whatever the object you pass, that class draw method first it will call, and then it will decorate the once it call the car, the actual existing class object draw method. You consider the draw method or the make method, then it will call then once the car object is created, then it is going to add the engine. If this is not clear at the moment, don't worry. Once we see this example practically, then you will understand this thing better. So as for the car decorator design pattern, the work of the decorator is to add a new functionality or behavior to an existing object without altering its structure. So whenever I'm saying car decorator, means you need to consider this is going to be an abstract class. So you cannot create an instance of this class. Then While I'm saying the decorator means you have to consider one of the child classes which implement this car decorator class. So what is the role and responsibility of this decorator class means it is going to add additional functionality or behavior to an existing object without changing or altering its source code. So you are not going to touch the existing car class source code, but you are going to add some additional functionality to this car class source, this car class object. How it is going to implement? Let's see step by step. So first of all, let me create one class project with the name car decorator design pattern to my existing solution. Let me make it this a startup project, right? So let me first create icar.cs interface. So this is nothing but your abstract product, you can say. So as we are going to implement, so this is going to be icar.cs. This class is going to provide the functionality which is going to be produced by the concrete classes, going to be implemented by the concrete classes. So this is my icar. This is the base component, or you can say interface that defines the operation that can be altered by the decorator. Decorator means now if you consider the first example, right? So if you consider the first example, this is the circle class and this is the draw method. And this draw method is going to be altered by the decorator class. So similarly, this is the iCar interface and this is the manufacturing car method. And this method is going to be implement the concrete car product, that is fine. But this method is also going to be implemented by the decorator class. This decorator class is going to provide some additional functionality to this decorator method. How it is going to provide additional functionality, that we will see in a time, right? That will see after some time. So let me first produce the actual car object, right? So actual car object means you need to create, I'm going to create one car called BMW car. You can give it any name as per your requirement. I'm going to produce a BMW car. So what this BMW car.cs file is going to do, it is going to create, right? It is going to create the car, BMW car, but without engine, right? So this class is going to produce the BMW car without engine. So what is the, going to do? It is going to produce the car body, car door, car wheels, car class, right? Everything it is going to be produced, but this is not going to implement, or this is not going to provide the car with engine, right? And this is the two-string method I'm overriding here, right? And this is going to return the car details. If call this two-string method on the BMW car object, then it is going to return what is the car name, right? What is the car body, car door, car wheels, car class, right? And engine. Engine in this case, it is going to be empty. Why? Because we have not provided the engine in this BMW car. So basically, this manufacture method, it is going to produce the car without engine. Later, we will see how we can use the decorator design pattern to add engine to this BMW, right? And these are the few properties I have defined to store different name. And you can make this method as read only because we are initializing at the time of creating, right? That is fine. So this is our concrete implementation. There might be several implementation like BMW car. You can create Audi car, you can create Mercedes car, right? Different car product you can create, but currently I'm going with the single car. So once this BMW car class is ready, you can see this is going to be my existing object. This is going to be my existing object, right? Existing object, and this class existing object having this manufacturing car method, which is going to produce the car without engine. Now, I cannot, I'm not going to change or alter this existing class. Let's assume that we do not have that flexibility. This class is implemented by some class library, which do not permit us to, they make this class as a cell, right? So that I cannot even use in the inheritance concept, right? So now what is my requirement? My requirement is I want to alter, right? I want to add some additional functionality to this BMW car, but at runtime. At runtime, I'm going to decide whether I need to produce the car with petrol engine or I need to produce this car, BMW car with a diesel engine. At runtime, I'm going to decide if you want to change sorry, change, I'm saying change is not the appropriate word. If I'm going to say, if at runtime I'm going to add some additional functionality, or if I'm at runtime I'm going to add some new feature to this existing BMW car project, then I need to go with decorator design pattern. So for decorator design pattern, what we need to do? First, we need to create one abstract class. Let's say I'm going to provide this car decorator, right? If you look at this image, right, for decorator design pattern, you need one car decorator. Then this car decorator, it is going to be an abstract class, and this abstract class is going to be implemented by two concrete decorator classes. Let me first create the abstract decorator class. This is going to be car decorator.cs, and this abstract decorator class is going to provide some functionality as it's an abstract class. So what you can do is you can have abstract member and non-abstract member. See, this is my constructor. So constructor means you can say yes, in interface you cannot create a constructor, but with abstract class you can have a constructor, you can have data member, you can have a method with implementation, you can have method without implementation, right? So if you observe, this is my constructor. So what this constructor is taking iCar object, and then whatever the value you are passing, that is in here, that is initializing this car variable. So what value you are going to pass to this car decorator? So to this car decorator, whenever you are going to create an instance, right, of this car decorator. So whenever I'm saying car decorator instance means you have to create an instance of the child classes that implement this car decorator. Whenever you are going to create an instance of the car decorator, you need to pass the existing car object that you want to decorate. And existing car object means what? Now the class which implement the iCar interface, that class object you need to pass. So if you go to this BMW car, does this car implement the iCar interface? Yes, it is implement the iCar interface. Then can I pass this BMW car instance to this constructor? Yes, we can pass. Why? Because this iCar is the parent class of this BMW car. So you can pass that instance to this iCar. And once you got the BMW car instance, that is what I'm initializing with this car variable. And then what is this manufacture car method does here? See, which object it is storing right now? Right now it is storing, let's assume that it is storing the BMW car instance. Then if I call this manufacturer method, then this method is going to be executed from which class, guys? Any guess?
From the BMW class.
Exactly. From the BMW car, this method is going to be executed. Once it call the BMW car manufacturer method, then what it will get? It will get the BMW car, right? Return this means the current instance of this class. It will return the current instance, and in the inside that instance, you will find these 5 properties, right? This car name, car body, car wheel, and class. Those are initialized with some value, but car engine it is not initialized. That means it will return the car without the car engine. Clear? Any question of this class code? What is this? Why we created this car variable? Because we want to store the existing car object which we want to decorate. Then what this car decorator constructor is expecting as one parameter? It is expecting the object which you want to decorate, right? And what is this manufacturer car method does here? It is simply calling the actual manufacturer method, right, of the existing object. Existing object manufacturer method it is going to call. But here, the most important functionality is this virtual car method. So guys, you just tell me why you need to make the method as virtual. What is the importance of a virtual keyword? Anybody can tell me? This is the simple OOPS concept.
So you can make it override.
Exactly. So if you make this method as virtual, then you can override this method in the child classes, right? And can we create an instance of this class, abstract class?
No, you can't create it.
Abstract class
No.
instantiation is not completed. Can anybody tell me why we can't create an instance of abstract class? See,
There's no.
Why we can't create means it might be possible that your class contains some abstract member, right? Suppose I'm declaring one abstract method, right? Then if it is possible, then it is also possible to call this abstract method. Why I'm getting this error? Oh, you cannot declare a body, right? Say you can say, as it's a abstract class, you can also able to create an abstract method. If it allows to create an instance of this car decorator class, then it is also possible to call this method using that instance. If I'm going to call this method, then where is the body? Body is there? No, body is not there. Then this is not possible. Body is not there. Then what this method is going to execute? This is the reason why it restricted us to create an instance of this car decorator class, because to restrict calling the abstract member of the class, right? So this is my car decorator class. So once the car decorator is done, then we need to create two concrete decorator classes. One concrete decorator for adding the diesel engine to the existing car object, another concrete decorator class for adding the petrol engine to the existing class, right? Let me add the class file. This is diesel car decorator.cs. And to this class, what I'm going to do, I'm going to copy paste this code. Okay. Let me copy paste and then explain. See, diesel car decorator. Definitely this class need one parameterized constructor. Why? Why? Because if you see this diesel car decorator implementing this car decorator abstract class. This car decorator abstract class having one parameterized constructor. Yes or no? Yes or no?
Yes.
So if
Yes.
the parent class having some parameterized constructor, then while you are making the inheritance relationship, then definitely if you are using the parameterized constructor, then you need to pass the value for that parameterized constructor or not? Yes, we need to pass. And for that purpose, we are using this diesel car decorator parameterized constructor. So while we are going to create an instance of this diesel car decorator, we need to pass the actual car object, and that actual car object, it will pass to the base class constructor. Clear this statement, guys? This is the simple OOPS concept. Your child class creating a parameterized constructor, the child class calling the parent class parameterized constructor, and whatever input value it received, the same value it is passing to the parent class. Clear, guys?
Yes.
Yes. So now, if you see this manufacturing method, first of all, it is calling the car.manufacturer. So what is this car? Where this car variable is declared? What this car variable is holding? Can anybody tell me? Where, first of all, where this car variable is declared?
It's the BMW object.
No, where this car variable is declared. If you go to the parent class, see, just to tell me, whatever the member you declare in the parent class, if those
In the
members are
interface.
available to the child classes, right? Parent class members are available, if not private. If any parent class member which is not private, is those members are available to the child classes or not?
Yeah.
Yes.
Yes. In the car decorator class, we are having this protected car member. Protected means what? This car member is going to be available within the same class as well as to the child classes. Yes or no?
Yes.
Yes.
So this car member, as it is protected, then this car member can available inside this diesel car decorator class. Is that member available?
Yes.
So,
Yes.
so whatever member you declared here, so can you call that member here? Can you
Yeah.
use that member here?
Yes.
So don't
Yes.
confuse with that. Say let me don't confuse with this variable. Let me change this to BMW car. If you are getting confused, now see, this is expecting the BMW car object, and it is passing that instance to the parent class constructor. Once it passed to the BMW car instance to the parent class constructor, the parent class, whatever variable you declared, that variable is initialized, and that variable is currently holding what it is holding. It is holding the BMW car instance, right? And then when I'm calling this manufacturer car method, so first of all, can I override this method here? manufacturer car, whatever the manufacturing method you declared inside the car decorator class, you declared that method as virtual. So is it possible to override that method here? Yes, it is absolutely possible. Why? Because in the parent class, you make the method as virtual. Virtual method means you can override the method. Now you guys just tell me why, if I'm calling this car dot manufacturer car method, if the car instance holding the BMW, if this car variable holding the BMW car instance, then this manufacturer method is going to execute from which class?
From the parent class, from part decorator.
Sorry,
From the parent class, from part decorator.
why parent class? Which
Because
class
it-
instance? Which class instance is this? See, if okay, let me explain you. You are having class A, right? And this class A having one public void M1 method, right? And you make this method, this is public M1 method. This is class B, and this is also having class B method. If I'm creating an instance of OBJ, right? And if I'm calling the obj.m1 method, then this M1 method is going to execute from which class?
From the A class.
A class. Why from A class? Because the obj variable pointing to an object which is of type A. Clear?
Clear.
So in this case, if this BMW, if this car variable, right, whatever the car variable you declared here, if it is holding an instance of a BMW car, right? If it is holding an instance of a BMW car, then if I'm calling this manufacturer car method, then this method is going to execute from which class?
Well, aren't we using a base keyword? So that's
Here I'm using the base keyword or I'm using the car instance.
okay.
So if I'm using the base, then in that case, it will call this method from the parent class. But here I'm not using the base keyword. Here I'm using the car keyword. Car keyword means what? Now, whatever the instance this car is pointing to, right? Whatever the object reference this car is pointing to, from that class only, this method is going to execute or not.
Yes, correct.
So in this case, this car reference variable holding an instance of a car decorator or an instance of a BMW car.
It's gonna be holding a BMW car.
So if BMW car, then this manufacturer car method is going to execute from which class?
From
Car
BMW,
decorator class or BMW car?
BMW car.
BMW car. Because see, if I want to execute this car decorator instance here, then why I'm going to override? I'm overriding means I don't want this method to be executed here. But this method, this is the reason why I'm making this method as virtual, right? So car dot manufacturer car. So once the manufacturer car method is executed, is this going to create the car without body?
Yes.
Right? So it is returning the car, but that car with all the properties are shared, but not the engine, right? So once this car is manufactured, once the car is manufactured, means you got the car, then you can call this add engine method. And while calling the add engine method, just pass the car, and then it is going to add the engine, right? Here I'm checking whether the car is BMW car or not, right? And then what I'm doing, I'm just checking if the car is BMW car. Then you know what is the syntax? This is the advanced syntax to check one object of which type, and if the object is of that type, then store that instance in the inside this variable, right? So in this case, car is BMW, it is going to return true if the car, right, whatever the car instance you pass, if that car instance is holding a reference to the BMW car, then it is going to do this. Otherwise, what you can do, you can do simply like this. Car dot, okay. See, here you cannot store this variable directly because inside this car it's an interface, right? So what I need to do, I need to change, I need to know. See, there are, see, in this case, like BMW car, there are might be multiple implementation of to this method, right? Like you can say Audi car, right? AUDI, Audi car. So simply you can implement something like this, right? So in that case, how you came to know whether that instance what this car engine is storing, it is of BMW or it is of Audi. For that purpose, you need to write something like this. Right? So what is this? This car is BMW car means it is checking whatever the object it is receiving is of this type or not. If it is of this type, then store that instance inside this variable, right? And once you store the instance inside this variable, it is going to be BMW car instance. And using that BMW car instance, right? You can see there is a property called engine, and I'm just setting the engine. And then I'm just printing diesel car decorator add a diesel engine to the car, and for that purpose I'm using this car. And whenever I'm using this car object means it is going to use this overloaded toString method to display all the car details, right? And else if the car is Audi car, right, whatever the instance you are passing, so instead of BMW car, I'm making it as generic so that you should not confuse whether it is BMW car or Audi car, or you can say it is the existing car. Better to say existing car, right? I'm making this as existing car, right? So what is this existing car, right? So you can not don't say that existing car, say only car, right? So what exactly this is going to happening? If the car is BMW car, then store the instance inside this variable, then set the engine. If the car is Audi car, then store the instance inside this variable and set the engine, right? Once everything is done, then just call the car, right? Car means in this case, this is going to return the whatever the toString method implemented that is going to be written. So these things is going to be written and these things is going to be printed here, right? So this is how the diesel car decorator class is implemented. Any question from anyone how this implemented and how this is working? Guys, any method, any statement which you are not understanding? Okay, so once the diesel car is completed, then next what we need to do, we need to create another car engine, that is petrol car, right? Let me create the petrol car decorator.cs class file. Let me copy paste the code. It is also going to do the same thing, right? Like the diesel car engine. It is going to be one parameterized constructor, which is going to initialize the base class car variable. Then we are overriding the manufacturer method. First, we are calling the actual car object, existing car object manufacturer car method. Then we are calling the add engine method. And then finally, we are returning the car. This add engine method first it will checking whether the car is BMW car or Audi car, right? So let me implement this also, whether the car is a BMW car or Audi car. If the BMW car, then it is adding the petrol engine, right? And if it is a Audi car, then also it is going to add this petrol engine, right? And then returning the car. So this is the same implementation like the diesel car implementation, right? Once the implementation is done, next what we need to do, we need to use these things, right? Where we are going to use these things, we are going to use these things inside the client code. So client code in our example, the main method of the program class is nothing but the client code. What we need to do? First of all, you need to create the actual object, right, which you want to decorate. So I want to decorate the BMW car. So create an instance of a BMW car. Here I'm storing this is on BMW car 1. So BMW car want that manufacturer. So in this case, if I call this manufacturer method, right, then what this manufacturer method is going to return, guys? It is going to return the BMW car with all these properties, but not the engine, because in this case this manufacturer car, if you are calling on BMW car one instance, then it is going to return the car, all the details you will find, but not the engine. Now what is our requirement? Our requirement to add a diesel engine to this car. If you want to add a diesel engine to this BMW car one, then what you need to do? For diesel engine, we need to create the car decorator instance which implement the diesel car. So we need to create an instance of a diesel car decorator. So I'm creating an instance of a diesel car decorator, and if you go and see the constructor, then the constructor expecting one parameter which should implement the iCar, or you can say it is expecting the parameter, right, of an existing car object which you want to decorate, which you want to that object, if you want to provide some additional functionality. And in this case, what additional functionality you want to provide? You want to add the engine. What engine you want to add? You want to add the diesel engine. Or that means what? That means you need to pass the existing car object to the constructor of this class. And what existing car you want to decorate? I want to decorate this BMW car. So I'm passing this BMW car one decorator to this class, right? BMW car one object to this class. Then all the responsibility will be taken care by this class. Then what I'm going to do? I'm going to call this car without diesel, a car with a diesel engine and a manufacturer car method. So one, we call this one, then you will see this manufacturer car method first call the parent class manufacturer method, which will create the car without engine. Then I'm adding the engine, and then it is returning the car with petrol with diesel engine, right? Now, if you want to add, see, let me see, create a different one. So Audi car. I want to create Audi car. So I want to add DJ. I want to add petrol engine to the Audi car. So what you need to do? You need to create an instance of a petrol car decorator, and to this instance you need to pass this Audi car and instance, and then this petrol car decorator, and you need to call this manufacturer car method using this instance, right? And this manufacturer car instance, what it is going to do? It is going to first call the Audi car manufacturer car method. If you go to the Audi car, right, where is the Audi car? This is my Audi car. This manufacturer car method will be called, right? Once that method is called, then what it will do? It will, where, yes.
Sir,
Then,
get set, those are the models you're using.
sorry,
There is you're using get and set, right? The
these
car
are,
class. These are the models.
so these are the properties of the class.
Okay. Okay, sir.
Why I'm getting this error?
You need a quotation mark at the end of BMW
Yeah,
auto.
I have to, right? So once you have the Audi car, then you need to pass that Audi car to the petrol car decorator class. Why? Because I want to add petrol engine to this Audi car. So this petrol car decorator will take the responsibility to add the, what you can say, to add the petrol engine to the car, right? So first of all, it will call the Audi car manufacturer car method. Once the car is ready without engine, then it will call this add car method to add the car, and one to add the petrol engine to the car. Once the petrol engine is added, then it is going to return the car, right? And once it is returned, let me call this application, then what, then see the output. See, first the BMW car instance, but in that case, see, if you see, while I'm calling this manufacturer car method, right, it is printing everything but the engine is empty. And this makes sense because if you go to the manufacturer car method, right? Manufacturer car, go to implementation. Right, manufacturer car method. It is returning, it is setting all these properties value, but it is not setting the engine property value. And whenever I'm printing the that car object here, then in this case, see guys, you might be having some confuse while printing this object, then how this data is displaying here. So in this case, what exactly happening? So in this case, this object class toString method is going to be execute, right? In this case, toString method is there, that method is going to display, or this method is going to display, right? And in this case, you can see that BMW car toString method is called, and this method is displaying these details, right? So then what I'm doing, then I'm calling, so this is optional. Calling the BMW car manufacturer method is optional. If you don't want, don't call this one also. That is also fine. I'm just showing that this method is not going to return the car with the engine. Right now, let me again run the application. Then you will see this diesel car decorated, add a diesel engine to the car. Which car? BMW car. Now you can see car name, car body, right? Car door, car doors, four car doors, right? And then car wheels, car glass, then MRF tire, and everything is a digit. Then you will see engine equals to diesel engine. And this makes sense. Why? Because while to this BMW car, we are using the diesel car decorator. And what is the responsibility of a diesel car decorator? It will add diesel engine to the existing car. And in this case, this is the existing car, and this diesel car decorator will take the responsibility to add a diesel engine to this existing BMW car one, right? And then if you see, I'm creating Audi car object, and I'm passing that Audi car to the petrol car decorator. What this petrol car decorator is going to do, it is going to add petrol engine to the Audi car. So in the second statement, you can see petrol car decorator added petrol engine to the car. Which car? Audi car. And here you can see engine equals to petrol engine. So this is how you can add what I can say, a new functionality to an existing card without changing or altering the existing card source code. So you can see BMW car code is same, Audi car code is same. We are not changing or altering these two car classes, right? But using this car decorator, right? We are adding additional functionality to the existing object at runtime. At runtime, I'm only going to decide which car engine I want to add inside this BMW car, or which car engine I want to add inside this Audi car. That is going to be decided only at runtime. But if you use the inheritance concept, right? Inheritance concept means compilation time. And if you don't want to decide what is going to happen at compilation time, rather you want to decide, well, I'm going to decide only at runtime to improve the application performance, then you need to use this decorator design pattern. And further, if inheritance is restricted means if this BMW car or Audi car, what you are seeing, if it is developed by someone else, and if they make this class as sealed, means inheritance is not possible. If not possible, then the only one and only solution is this decorator design part. That is what I'm showing. Clear, guys? Clear?
Yes.
If still
Yes.
doubt, I will give you another example so that you will understand this thing very clearly, right? So see, whenever you are same kind of requirement, then you need to go with the decorator design part. Suppose you are developing one food delivery app for Zomato or some Swiggy, right? Uh, in any kind of application you consider, right? You are developing. And suppose the requirement is that the client can simply order a plain pizza, or the client can also order the plain vegetable pizza, or the client can also order the chicken pizza. But behind the scene, if you see, whatever the plain pizza, on top of the plain pizza, I need to add vegetable to make it as vegetable pizza. On top of the plain pizza, if the client want chicken pizza, then what I need to do, I need to add chicken on top of the plain pizza to make it as the chicken pizza, right? So in this case, you can go and implement the decorator design part. What you need to do? So you need to introduce the pizza decorator. And this pizza decorator is going to be extended into classes. One is vegetable pizza decorator, another one is chicken pizza decorator. So what you need to do, you need to, this is your existing pizza, you need to pass this existing pizza to this pizza decorator. And if the client wants the vegetable pizza, right, then the vegetable pizza decorator class is going to first will call this plain pizza method, and then it will add vegetable to make it as the vegetable pizza. If the client wants the chicken pizza, then this chicken pizza decorator class will come into the picture. It will first create the plain pizza, and once the plain pizza is created, then it will add chicken to on top of the plain pizza to make it as chicken pizza. And once the chicken pizza is created, then it will return the chicken pizza to the client or customer. And in this case, if the client interested for vegetable pizza, then the vegetable pizza decorator class will create the vegetable pizza and it will return that vegetable pizza to the client. So this is one of the most what I can say. If you go and watch some of the YouTube videos or some internet articles, then almost all or everyone giving this example. So I thought, let me also give this example, right? So let us implement this class diagram first, right? So, oh, I have forgot to explain the class diagram, right? Right. So I have forgot to explain the class diagram. Let me explain the class diagram first. See, so the class diagram means you can see at the top of the see, this is your component, this is your decorator, this is concrete decorator A, concrete decorator B, and this is concrete component. In our example, this component is nothing but your iCar interface, and this concrete component is nothing but this component is iCar interface, and this concrete component is nothing but your BMW car and Audi car. Right? This decorator, this is nothing but your car decorator, and you can see there are two concrete decorators also. This is abstract class, this is diesel car decorator and a petrol car decorator. So at the top of the car, you can see iCar interface, and in our example, this iCar interface is having this manufacturer car method. This interface is implemented by BMW car concrete class, right? And provide implementation for this manufacturer car method. If you want, you can also put some other operations, right? Also, this iCar interface is implemented by this decorator abstract class, and also provide this manufacturer car method implementation, right? And this decorator class implement this manufacturer method with virtual keywords, so that this manufacturer car method is also going to be implemented by the concrete decorator class A and the concrete decorator class B. So in our example, this component is nothing but your iCar. See, it is going to declare the operation that are going to be altered, right? Altered by the decorator, right? This is the component, right? And then you can see concrete component. Concrete component means this is the concrete component, right? So you can have several variations. Here I'm putting BMW car, here I'm putting the Audi car. What is the responsibility? It is going to provide the car without engine. And this object is going to be extended at runtime. Onto this object, we are going to add some additional functionality at runtime, right? So then the next component is a decorator. This is going to be an abstract class. And this decorator is also going to implement this component interface. That means if you look and say this car decorator class, it also implements the iCar interface and provide implementation for this manufacturer car method. But here you can see it is making this method as virtual. Why? To making this method as virtual, because the actual implementer, the actual decorator classes, right? They are going to provide implementation to this virtual method, and they are going to provide some implementation for this manufacturer car method, as well as some added operation. Added operation in this case, it is going to provide added operation means the additional operations, right? The additional operations is nothing but adding the engine. So these are the different components involved in decorator design pattern. So simple sense, you can see component, this is an interface. In our example, this is the iCar. This interface contains member that are going to be implemented by concrete component classes and decorator classes. So if you see, this is the component, this component is going to be implemented by the concrete component classes. This is your concrete component and also the decorator classes. Concrete component, this is going to be a concrete class. In our example, this is BMW car or Audi car. This class simply implements the component interface. You can see in our example, BMW car implements the iCar interface and provide implementation for the manufacturer car method. So you can see it is implement the iCar interface and provide implementation for the manufacturer method. And in this case, also it is implement the iCar interface and provide implementation for the manufacturer car method. Decorator means it is going to be an abstract class, and in our example, it is the car decorator. This class implements the iCar interface and contains a reference to the component instance. So in this case, you can see it contains a reference to the component instance. This is the variable which is referring to the component instance, right? Whatever the component object you are going to create, that component object you can store inside this variable. And it is also implementing this method, right, and making this method as virtual, and this is nothing but your constructor. This constructor is nothing but it is going to accept the existing object, right? If you look at this diesel car decorator, petrol car decorator, it is expecting the existing car object which you want to decorator. In this case, I'm passing BMW car. In this case, I'm passing Audi car. And this concrete decorator AP means these are nothing but the actual decorator classes which implements the concrete decorator class. And this actual decorator class is going to provide the additional functionality which you want at runtime. In this case, you can see once the car object is ready, then we are providing the additional functionality, that is adding engine. So this is the four components involved in the decorator design pattern: component, concrete component, decorator, and concrete decorator. And when to use means we want to use this design pattern when we want to add a new functionality to an existing object dynamically. So in this case, you can see these are my existing object BMW car 1 and Audi car. And to this existing object, I want to add some additional functionality at around that is adding engine. So in such kind of situations, you need to use which design pattern? Decorator design pattern. Clear, guys?
Clear.
Okay. Now we need to implement this pizza application. See, in pizza application, first of all, you need to declare one interface. This interface pizza having one method called make pizza. Then what is going to happen? This make pizza method is going to be implemented by the plain pizza. Plain pizza is nothing but this is your component interface. This is your concrete component. This is going to make this plain make pizza method. This plain pizza, it is nothing but your actual existing object, right? Then what is required? The client might be required for chicken pizza or might be required the veg pizza. For that purpose, so to add additional functionality on this plain pizza at runtime, we are making use of this pizza decorator class. So this pizza decorator class, it is going to be an abstract class. Inside this abstract class, three things are going to be there. One reference to this make pizza method, right? One reference to the actual pizza object, or you can say the existing pizza object. Using this constructor, what we need to do? We need to initialize this variable, right? Pizza variable. And then this make pizza method, it is going to be, as it is implementing this pizza interface, so it has to provide implementation for this make pizza method. But this make pizza method internally, it is not doing anything. It is simply calling the make pizza method of this plain pizza class, right? And then it will going to make this method as virtual, so that the chicken pizza decorator class, it is going to implement this method, and veg pizza decorator class, it is also going to implement this make pizza method. And inside this class, what is going to be required? So as the pizza decorator class having one parameter as constructor, so it should, the child class should have a constructor which should be a parameterized, and this parameterized constructor is calling the parent class parameterized constructor. And same in the case of veg pizza. Then it is calling this, then it is providing implementation. It is not implementation, it is overriding this make pizza method here, because this make pizza we need to make as virtual. So we are overriding here. Once as part of this make pizza method, we are calling the make pizza method on this pizza object, right? This pizza is nothing but this plain pizza. This plain pizza object, using this plain pizza object, we are calling this make pizza method. And once the make pizza method is done, then we are calling this add chicken. And here we are calling the vegetable, add vegetable. So in this way, This is the class diagram of this application, what we are going to discuss. And from the client code, first of all, we will create an instance of a plain pizza. And then based on the requirement, what the client want, whether the client want chicken pizza or veg pizza, the appropriate decorator we will use. And to this decorator, we will pass this plain pizza as a parameter to the constructor. This is what we are going to implement. Let us first create the project. Okay, let me complete all this. I'm adding a new project to the solution, right? Let me create the component interface. What is the name? The name is going to be pizza.cs. It is going to provide some functionality which can be altered, right? Altered in the sense going to be decorated by the decorator. So I'm creating this class with one method, right? This is going to be an interface, and this is going to be the method make pizza. So let me do as it's an interface. Let me give this as iPizza. Okay, let's keep it as a pizza. Why I'm going to do the changes in all the classes? You can do this. So then what I need to do, I need to create the concrete component, right? The concrete component means the class which is going to implement this. Let me first make this a startup project. The class which is going to implement the pizza interface and provide the implementation for the make pizza method. But in this case, this is the existing object, and this existing object is going to return the pizza, plain pizza, right? It is going to return plain pizza, right? At runtime, we'll see this is going to my existing object, and runtime, we'll see how we can add chicken to this pizza, and how we'll add vegetable to this pizza to make it as the chicken pizza and vegetable pizza. The third thing what we need to do is we need to create the pizza decorator. This is going to be an abstract class. This abstract class is going to be have three things, right? What are the things? First, it will have a reference to the actual pizza, or it will have a reference to the existing pizza object. This is nothing but reference for the existing pizza object, right? Then we need to have one constructor, parameter as a constructor, and this parameter as a constructor is taking or expecting one value of the existing pizza type. And once it receives the existing pizza object, it is going to initialize this variable, and it is having the virtual make pizza method. And inside this virtual make pizza method, it is calling the actual pizza class make pizza method. And as this method is virtual, so it is going to be implemented by the concrete pizza decorator classes. And again, we are having two concrete decorator pizza decorator classes. One decorator pizza decorator class is going to add chicken. Let me give this name as a chicken pizza decorator, right? And then let me copy paste the code. The code what I'm going to show, it is exactly same as the previous example code, right? So you can see this is the constructor. It is calling the parent class constructor. Whatever object it receives, it passes to the parent class. And in parent class, this is going to initialize this variable, right? Then it is having this make pizza method, right? And in this case, you can see, first of all, it is calling this pizza means this is the parent class variable, and this parent class member are available to the child classes. Using this variable, I'm calling this make pizza method, right? And once the make pizza method implementation is completed, then I'm calling this add chicken method. So what this add chicken method will do, what this make pizza is written, if you see the pizza class, plain pizza class, it is returning me plain pizza. So and after the plain pizza, it is showing chicken added. So, and then it is returning these things, right? So plain pizza plus chicken added is going to be written by this make pizza method. And this is for chicken pizza decorator, right? Now what I'm going to do, I'm creating another decorator, that is veg pizza decorator. And this veg pizza decorator class is going to add vegetables to the plain pizza. That means on the existing plain pizza, it will add vegetables, and it will make that plain pizza as a vegetable pizza. So the same things is going to be done. The constructor, which is calling the parent class constructor, this is the overrideable method. First, it will calling the plain pizza class make pizza method, and then it is calling the add vegetables method to add vegetables. And finally, whatever this method return, then it will add these strings, and that is going to be written by this make pizza class. So once this is done, then next what we need to do, we need to use these things in our class in the client code. See, first of all, you need to create an instance of a plain pizza method. And in this case, if you call these things, right, if you call this plain pizza, I mean on this plain pizza object, if you call this make pizza method, then it will return you plain pizza. That is what I'm going to show you after show you, right? So let me first run this application and show you this thing so that you should not be confused. So the application is running. See, the first statement is plain pizza. Why it is plain pizza? Because we are not decorating anything. We are simply creating the plain pizza and calling the make pizza method. So it is going to return me plain pizza, which I don't require anymore. So I'm just commenting this. So now what is my requirement? My requirement is I want to add chicken on top of the plain pizza. So if you want to add chicken on top of the plain pizza, then which decorator you need to use? You need to use chicken pizza decorator. And what you need to do, first of all, you need to create the plain pizza object, and then you need to pass that plain pizza object to the constructor of chicken pizza decorator, and the rest is same, right? This chicken pizza decorator will accept the plain pizza object. This plain pizza object is again passed to the base class, right? Base class in the sense this pizza decorator class object constructor, and this constructor will initialize this pizza variable with the plain pizza instance, right? Then what is going to happen? It is calling the make pizza method. So this pizza variable which is declared here, it is containing an instance of a plain pizza, that's a plain pizza class. So from the plain pizza class, this make pizza method is called, and this will return plain pizza. And then we are calling this add chicken method, which is going to add chicken. So plain pizza plus add chicken. Then the same thing, right? Then the same thing I'm doing with the vegetable pizza decorator, right? I'm calling the passing the plain pizza object to the constructor, and then I'm calling the make pizza method, and whatever they return, I'm simply printing here, right? I'm printing here, and I'm also printing here. Now, if you run the application, then you will see that, see, plain pizza chicken added using chicken pizza decorator, plain pizza vegetables added using vegetable pizza decorator. Clear, guys? Guys, clear?
Yes, sir.
Okay. So this is all about your decorator design pattern, right? Next, what we are going to discuss, bridge design pattern, which is also belongs to the structural design pattern category. Right. Let us first see the definition. So what is bridge design pattern? As per Gango for definition, the bridge design pattern decouples an abstraction from its implementation so that two can vary independently. So what it means? It means it is saying that there are two things. One is abstraction, another one is implementation. And according to bridge design pattern, it decouples the abstraction from its implementation. That means abstraction is going to be developed as an independent layer. Implementation is going to be developed as an independent layer. And this bridge design pattern allows us to implement development, right, independently. So you can changes the abstraction layer, which will not impact the implementation layer. Again, if you changes the implementation layer, it is not impact the abstraction layer. That means both layer can develop independently. This is the main objective of a bridge design patterns, right? So in bridge design pattern, there are two parts. The first one is abstraction. The second one is implementation. I will show you what is abstraction, what is implementation. Don't worry. The bridge design pattern allows both abstraction and implementation to develop independently, and the client code can only access the abstraction part without being concerned about the implementation part, right? The client will use this abstraction. This abstraction internally used for implementation, and the client will not be worried how the implementation is going to be implemented there, right? The bridge design pattern separates the abstraction hierarchy and implementation hierarchy into two different layers. So in our application development, you will see we will develop abstraction as a different layer, implementation as a different layer. So if we change in any layer, and we will also make sure that once we change any layer, then it should not affect the other layer in the hierarchy, right? So if this is not clear at the moment, don't worry, we will see some real-time example to understand this concept. Right. Look at this image. This is the client. This is the abstraction layer. This is the implementation layer. The client will use the abstraction layer. The abstraction layer will use one of the implementer of the implementation layer to do the operations. Right. For example, if you okay, let us start with this implementation layer. So this persistence implementation is nothing but your implementation layer. In this implementation layer, we are having two implementer. One is file system persistence implementer. Another one is database persistence implementer. This is the implementation is done. This is the abstraction layer. This is the persistence. What is our requirement? We need to save an object and we need to delete an object. But what is the required thing? Now, whenever I'm saving an object, I need to save the object either in the file system or into the database. Similarly, while I'm going to delete an object, I need to delete the object either from the file system or from the database. That means what? Now, whenever the client saving an object, then the client will use the abstraction class save method, and this save method internally make use of any one of the implementation class. If the client want to save the data in the database, then this persistence class, right, it will make use of a database persistence implementer class. If the client want to save the data into the file system, or if the client want to delete the data from the file system, then this persistence layer, right, internally make use of a file system persistence implementer. That means what? That means this persistence layer, based on the requirement of the client, it will make use one of the implementer classes, right? Either it can use file system or it can use database persistence implementer. But the behind the scene, you can develop this layer independently. You can also develop this layer independently, and there is no relation between this layer. Yes, there is some relationship. Otherwise, operations will not be possible. But the relationship is so loosely coupled that you can develop this abstraction layer independently. You can develop this abstraction layer independently, right? Again, so what is the development independently means? Suppose I want to add a new implementer class, right? New implementation class. You can add here. No issue with the abstraction layer. There is no issue with the abstraction layer with the new classes what you added here. Even if you add a new persistence class here, then there is no issue with the implementation layer. That means both can develop independently, right? So let us see some real-time example to understand these things very clear, right? So now you can see this is my abstraction layer. This is my implementation layer. And here, who is the client? Client is nothing but you and me people, right? The TV, what you can see, the smart TV is nothing but your abstraction layer. And the remote control, what you are seeing here, it's nothing but your, sorry, the TV, the smart TV, the Samsung TV, the Sony TV, what you are seeing here, it is nothing but your implementation layer. The actual implementation is provided here. This remote control, what you are seeing, Sony TV remote control, Samsung TV remote control, these are nothing but your remote control, means these are nothing but your abstraction layer. And abstraction will use one of the implementation layer, right? Suppose you are clicking on the turn on button on the remote control. So do you think that actual implementation is provided here, or the actual implementation is provided inside the TV? Inside the TV only. So when you click on this button, then it will use the one of the implementer. Which TV remote control you are using? I'm using Sony TV remote control. So it is will use the Sony TV implementation layer to turn on the TV. While I'm clicking on the turn off button, right? Then based on the remote control, so Sony TV remote control, it is for Sony TV implementation class. So it will going to remove the what I can say, sorry, turn off means it is going to turn off the TV. Again, if you are setting the channel, then you can set the channel here, but the actual implementation is there. Similarly, for this, what I can say, Samsung TV remote control, right? Now, if I'm going to introduce another implementer, that is so what I can say, MI TV, right? Then there is no issue with this existing layer. MIT means it is a brand new implementation. There is no link between this abstraction TV remote class with the MITV or the Samsung TV remote class with the MITV, right? So if so in that case, you can create this implementation layer, you can create this abstraction layer independently, and once you add a new implementation, then it will not impact the existing abstraction, and if you add new abstraction, then it will not impact the existing classes. See, in this case, if I add a new implementer class, does that have any that make any changes with this two remote control? No, they will not make any impact. If I add a new remote control here, does that affect these two implementer classes? No, they will not affect at all, right? That means this implementation classes you can develop independently, and these abstraction classes you can also develop independently, right? Let us see how we can implement this using the bridge design pattern. So I will explaining the bridge design pattern, and then I will explain you the what I can say UML diagram or class diagram. Let me add a project with the name bridge design pattern to our solution. Let me make this and start a project. Close all but this. Okay. So let us create the LED TV. So create an interface with the name ledtv.cs. Okay, let me create an interface with the name ledtv.cs. Make this as interface. Then copy paste this code. Right. This is going to be an interface that acts as a bridge between the abstraction layer and the implementer layer. Right. This interface is going to act as a bridge. This interface will make it possible that in the abstraction layer will be developed independently and implementer layer is going to develop independently. And this interface provides the functionality that is going to be implemented by the concrete implementation classes, right? So concrete implementation classes means implementation layer classes, right? And in our example, how many implementation layer classes we need to define? One is for Sony TV and another one is for Samsung TV, right? So let us create the implementation classes. Let me first create the Samsung LED TV.cs. This is one of the implementer classes. Samsung LED TV.cs. And then I'm going to copy paste this code. So this is very straightforward code. No need for any explanation. Simply implementing the interface and providing implementation to these three methods, which are declared inside this interface. The next one, what we need to do, we need to create the Sony LED TV.cs class file. This is going to be another implementation classes. And this implementation classes is also going to do the same thing as the Samsung implementation classes, right? Means what? It is implementing the iLED TV interface and providing implementation for all the three abstract method what declared inside this interface, right? So our abstraction layer is done. Next one, what we need to do, we need to define the, these are nothing but implementation, not abstraction. These are nothing but your implementer classes, or you can say implementation layer. Next, what we need to do, we need to create the abstraction layer. For abstraction layer, what I'm going to do, I'm going to create one abstract class. So what is the name of the abstract class? Abstract remote control, right? This is going to be abstract remote control.cs, and if you see the code, it's also identically to iLED interface. But see, I'm saying it is identical to iLED interface. But if you want, you can provide more. See, in this case, this iLED TV, whatever the name, switch on switch off set channel. So I'm giving the same name here, but you can give a different name, right? Suppose I'm giving remote switch on, right? Switch off. Like this, you can also give. There is no issue. What is the important here is this way. you can keep the name as it is, or you can give different name, no issue. But in this case, the important is ILDTP component, right? If you remember, this is the interface. This is implemented by these two classes, and here I'm using that ILDTP reference variable, right? So then what you need to do, then you need to create two concrete remote control. One is Samsung remote control to control the Samsung TV, right? Let me create a class file. Then let me copy paste the code, right? So what I'm going to do here is, if you remember, why I'm getting this error, because we have changed the name, right? So we need to also change the name. Yeah, switch remote to the switch remote control, right? So if you see in the abstract class, we are having one variable, protected variable, and that variable need to be initialized first, right? Initialized first means using the constructor. Why? Because which TB you want to control, that TB object you need to pass here. And this remote control is specifically designed to control the Samsung LED TV. So here you need to design like this, right? Samsung LED TV. So whenever Samsung LED TV means Samsung LED TV instance, you need to pass while you are creating the Samsung remote control. And that Samsung instance is going to be stored inside this LED TV. So here, whenever you call the remote switch on button, then it is internally going to call the Samsung LED TV switch on button. So where is the Samsung LED TV? Samsung LED TV is there. So these things is going to be print on the window. So whenever we call the remote switch off button on the LED TV, then in this case, as this LED TV holding the Samsung LED TV instance, it is going to execute this method internally. Similarly, same in the case of a set channel, right? Once the Samsung remote control is done, then we can add Sony remote control, right? And then again, this method is going to do the same thing. This remote control is specifically designed to work which TV? Sony TV, right? Let me copy the name remote, because we have changed. See, I'm changing this remote to make you understand that both method are different. So you can give different method, right? So again, using this constructor, you need to initialize the Samsung LED TV, and again, you are having this method. So now you might be have one question: why not we create one control class, and to that control we need to provide the appropriate functionality, right? So instead of creating Sony remote control, instead of creating Samsung remote control, why not we create one class with only the name remote control? And that is also going to be acceptable. Yes, that is acceptable. But what is our intention? Our intention is that we need to separate the abstraction layer from the implementation layer. As our intention is separate, for each kind of implementation classes, we are creating one abstraction classes, so that there should not be any link between the abstraction layer classes and the implementation layer classes, right? So we have done with our implementation. Now we need to use the things in the client class, right? So from the client class, what we need to do, first of all, we need to create, right? So switch and switch off. Why we are getting the error? Because we have changed the name from switch on switch off to remote switch on switch off. See here, I am going to use the remote control class switch on switch off method, not the actual class Sony TV or LED TV switch on switch off. Because as a user, I'm going to use the remote control. Remote control will internally use the implementer classes. So here we are the user, and this Sony remote control we are using, and we are clicking on the switch and button on the remote control, not the actual TV, right? And then I'm using the remote control to set the channel, using the remote control to turn off the TV. And what is important? The important thing is that while creating the instance, you need to pass the actual TV object which you want to control, right? That's it. Now, if you run the application, you will see the output as expected. Clear, guys? So now if you want to add any new implementer classes, you can add. There is no link between the existing classes and the new implemented classes. If you want to add a new remote control, you can also add. There is no link between the existing classes, right? So if you see this implementer class, right, is there any, we specify the concrete class name, whether Samsung LED TV or Sony LED TV? Is there anything like this, guys? Or inside this class, did we mention any concrete component class names?
No.
That means
No.
if you modify or change these classes, is it going to affect the actual product classes, actual implementer classes? Is there any link? So you can see Samsung LED TV. Did we mention anything where about the concrete Samsung remote control or Sony remote control?
No.
No.
No. That means if you modify this switch and method, there is no issue, right? Right. And if you add new implementer classes, or if you add new abstraction classes, right, then there is no issue, because both can develop independently, right? And this is the main objective of bridge design pattern, and this is possible only because of this ILDT, which is nothing but your bridge interface. This interface makes it possible to develop both the abstraction layer and the implementation layer independently. If you go to Sony LED TV, here we are using ILED TV bridge interface. This ILED TV, this is nothing but your bridge interface. This is nothing but your bridge interface. If you come here, right, if you come to abstraction, again it is using this bridge interface, right? And this interface, bridge interface, makes it possible to develop both abstraction layer and implementation layer completely. And as a user, we are using the abstraction layer, right? Remote switch on, set channel, remote switch off, these are nothing but your abstraction layer, right? And this abstraction layer will make use of one of the implementer layer, right? Whichever implementation layer it is going to use, that implementation you need to pass as a parameter to the constructor of the remote control. Now, if you read the definition, then you will understand these things very clearly. The bridge design pattern allows both abstraction and implementation to be developed independently. Here you can say these implementer classes and these abstraction classes you can develop independently. The client code can only access the abstraction part without being concerned about the implementation part. And here you can see the client is only calling the method which are defined inside your abstraction layer without being concerned about how these methods are implemented in the implementation layer. That will be taken care by the abstract remote control, right? And if you see bridge, so as per bridge design pattern, the abstraction and implementation should be in separate layer. Here persistence in this example is the abstraction layer, persistence implementation is the implementation layer. Now if you want to add any new implementation, or if you want to remove any of the existing implementation, then it will not affect the abstraction layer. This is the advantages of bridge design pattern. So once we understand the example, let us understand the class type. See, so in the case of a class diagram, right? So you can say this is my implementer interface, or you can say this is the bridge interface. This bridge interface is implemented by complete implementer class. So in this case, this is nothing but your iLED TV interface. This is the bridge interface. This iLED TV interface is implemented by Sony LED TV and Samsung LED TV. And whatever the operations defined here, right? Those operations are going to be implemented by these two concrete classes. This is the abstraction layer. It is not inheriting this implementation class. For this abstraction class, this implementer class is not the parent class. Rather, it is using the implementer. Using the implementer means inside this abstraction, you will see a variable of this type. And if you come to our example, this is our abstraction class. This is nothing but your implementer variable. It is not implementing this class like this. It is just using the implementer variable. And then inside this class, you can declare the operations. Here you can see I'm declaring the operation. It is not needed the operations name is going to be same as this operation names. As you can see, I'm giving different name, but if you give the same name, then it is also fine. And then this concrete abstraction classes, they have to implement this abstraction. They have to provide they have to initialize this implementer class. They have to provide implementation for these operations. Now the client is going to use this abstraction on this concrete abstraction classes, and this concrete abstraction class will internally make use one of the implementer classes. So what are the component? One is implementer, another one component is a concrete implementation classes, another one is abstraction, and the last one is the concrete abstraction. Clear, guys?
Yes.
Yes.
Now, when to use bridge design pattern in real-time application? When we want to hide the implementation details from the client. Now, if you see what are the actual implementation method name, how the method is actually implemented, the client have no idea. You can see the client have no idea because client is only using the abstraction layer when you want to hide. When we want to selection or switching of the implementation to be at runtime rather than at design time, right? So if you want to select now, I want the remote control to access the Sony TV. Later, I want the another remote control to access the Samsung LED TV. That means if you want, see, we are implementing in this way, but it's not. But there is no issue that if you pass the Sony LED TV here, right, and Samsung LED TV here, then also it is going to work. That means if you want to switch, right, for this example, this is not the ideal example for this scenario, but later I will show you, this is a scenario where you want to switch these things, implementation at runtime, then also you need to use. When both abstraction and implementation should be extensible by the subclasses, you can see this is the abstraction, it is extending in the subclasses, and this is the abstraction, and again it is extending into the subclasses. We want to avoid tight coupling binding between abstraction and implementation, and in this case you can see in the abstraction layer we never used any of the concrete class name, concrete implementer class name, and you can see in nowhere you will find the concrete implementation class name in the abstraction layer. Again, in the implementer layer, you will not find the concrete abstraction classes because there is no tight coupling. Means we are going to avoid the tight coupling. The changes in the abstraction implementation of the abstraction should have no impact on the client, right? If you change, right, any of the abstraction, then it should not have any impact on the client, right? Whether you change the abstraction implementation, it will not impact the client. So this is how you need to implement a bridge design pattern. Let me give you another example so that you will get a better idea. Right. So this is, we have already discussed what is bridge design pattern. In bridge design pattern, there are two layers. One is abstraction layer, another one is implementation layer. Then what is as per the bridge design pattern? What this bridge design pattern tells, now if you do any changes in the implementation layer, then it should not affect the abstraction layer. And in the same way, if you do any changes in the abstraction layer, then it will not affect the implementation layer. This is the this is the objective of bridge design pattern. Let us understand what example we are going to implement. We are going to implement the sending message functionality, right? On the left hand side, you can see the abstraction layer. Let's say you want to send a message to the corresponding person. On the right hand side, you can see two implementer. You can email the message, or you can SMS the message to the corresponding person. So you have two options to send the message, and the abstraction layer will use one of the available option, right? One of the implementer to send the options, right? But this is one of the example of bridge design pattern. You are having abstraction layer separately. You are having different implementation layer separately. The abstraction layer will use one of the implementer to send the SMS. Sometimes it will make use of an email class. Sometimes it will make use of a SMS class to send the message, right? So let us implement this with the bridge design pattern. Before that, let me explain you the class type. So this is the implementer layer and this is the abstraction layer. In implementer layer, we are going to create an interface with the name iMessage sender. And this iMessage sender interface having one message called send message. It is taking the string message as an input parameter, and that message we are going to send to the customer. Again, this implementer interface, or you can say this is the bridge interface, it is implemented by two concrete implementer class. One is SMS message sender, another one is email message sender, right? This SMS sender class, right, implement this implementer interface and provide implementation to the send message. And this email message sender class is also doing the same thing. In this case, it is implementing the send message method of the iMessage sender interface and providing implementation. In this case, it is sending the message to the customer mobile number. In this case, it is mailing the message to the customer email ID. So these are the two concrete implementer classes, and this part is nothing but your, what you can say, this is your implementation layer. And coming to the abstraction message, abstraction layer, we are creating an abstract message abstract class. This abstract message abstract class will have a reference. I mean, it will create one variable of type this iMessage sender, and this class is also having one abstract method, and this abstract method is going to be implemented by the concrete abstraction layer. One is long message, another one is short message. So we can send sometimes we need to send some kind of short message, right? For long message, there is no issue with the word length, but for short message, there is a minimum length, maximum length limitation is there. For example, if you are sending short message and you can send maximum of 100 characters, that you can, that validation you can provide here. So but for long message, there is no such restrictions, right? And here you can see both the classes implement this abstraction. They have to do three things. First of all, they need to create one constructor which should initialize this class variable, and they should have implement this method, right? And there are two implementation classes. Let us proceed further and implementation this example so that you will get some more idea, right? Let me add a, okay, let me first clear all these things, close all documents. Let me add a new project. I'm making this as a startup project, right? Let me implement this iMessage sender interface. iMessage sender.cs. This is going to my interface, or you can say component interface, right? Or you can say this is going to my bridge interface, which will act a bridge between the abstraction layer and the implementation layer, right? And in this interface, we are simply going to define one method that is going to be implemented by the concrete implementer classes. And as per our requirement, we are having two concrete implementer classes. One is SMS sender and one is email sender, right? Let me create the SMS sender class. Let me copy paste the code, and this class is very straightforward. What this class is doing, it is implementing the iMessage sender interface and providing implementation to the send message method. We are simply saying, printing this, whatever message you are trying to send, we are saying this message has been sent using SMS, right? That is the SMS sender concrete implementer classes. Next one, what we need to do, we need to create a class for email sending, and for that purpose, we are creating email sender class, right? Let me create the class file, email message sender.cs. And this class is also going to do the same thing. It is also going to implement the iMessage sender interface and provide implementation for the send message method. And here we are just simply printing this message, whatever message, this message has been sent using the email, right? So our implementation layer development is there. This is my bridge interface. This interface is implemented by this concrete implementer class and this concrete implementer class. So two concrete implementer classes, and this is my implementer interface now. Now we need to start developing the abstraction layer. First of all, we need to create one message variable, abstract message class. So it is going to be concrete class, and this class is having two things. One is a variable which is pointing to the bridge interface. This variable is pointing to the bridge interface. You can say iMessage sender. This is the bridge interface, and we are having one what I can say abstract method, and this method is going to be implemented by the concrete abstraction class. So we are having two types of message. One is short message, right? So this is one of the concrete abstraction layer, and inside this short message, what we need to do, we need to do some kind of validation. What validation we are going to do? First of all, this class is implementing this abstract message class. So if it is implementing this one, then two things. First of all, two responsibilities there. First of all, okay, let me do one thing. This is abstract class. What I'm going here, public abstract message, and what I'm going here, this dot message sender equals to iMessage sender. Right, and here I'm initializing that variable, right, message sender. And here what I need to do, I need to call this base class variable, and the base class will take the responsibility to initialize this variable, right? I'm not going to initialize, sorry, I'm not going to initialize that variable here. The variable initialization will be delegated to the abstract message abstract class. See, that means that in the child class, we need to pass the actual object using the constructor, and we need to override this one. In the child class, the constructor is delegating whatever the object it received, it is passing that object to the base class constructor, right? And in the send message, what I'm doing, I'm checking if the message length is less than 10, then I'm only going to send the message using the send message method. And what this send message is going to hold, it is going to hold the actual implementer instance, whether it's SMS message sender or it is email message sender. That instance is going to be stored inside this variable, and using that variable I'm calling the send message method, and this method, either this method or either this method, is going to be executed at runtime, right? And then if the message length is greater than 10, then it is going to print this method that unable to send the message at the length is greater than 10 characters, right? Then what we need to do, next thing we are going to create the long message class. So long message class, it is going to be like this. It is also going to be very straightforward, right? Let me copy this code, right? Let me copy this code. And here what I'm going to do, the constructor is going to be long message, right? And here it is also going to inherited from the abstract message. And here we do not have such kind of validation. Whatever the message we received, we need to send to the customer, right? So the implementation layer is also done, right? Next, what we need to do, we need to use this abstraction layer in our client code, right? Now, what I need to do, I need to modify the main method, right? Let me show you the code. First of all, we are giving the user, please select message type. What message you want to send? You want to send long message or short message? If you want to send long message, then type 1. If you want to send short message, then type 2. And whatever the user type, that we are going to store inside this message type area. And once the user select the type, then we are saying, please enter the message that you want to send. And whatever the user provide the message, that what we are going to store inside this message variable. And if message type equals to 1, message type equals to 1 for long message, what we are going to do, we are going to create an instance of a long message, and here we are using email message sender. For long message, we are using email message sender, and we are calling the send message method. And if the user select the type as short message, right, then we are creating the instance of a short message, and we are sending the short message using the SMS sender, right, and then calling the send message method. Let me run the application. Select the message type. What message you want to send? I want to send one long message. Long message is going to be sent by using email sender. Hello, welcome to .NET tutorials. See, hello, welcome to this message has been sent using email, right? Now what I'm going to do, I'm going to select a two for short message. Whatever the message, good morning. I'm sending good morning, right? See, unable to send message because length is greater than 10, right? Now I'm going to select a short message to, and what is the message? Welcome. See, welcome, this message has been sent using SMS. If you want, then you can also alter the things, right? If you want, you can put that thing here, and here you can also use these things, right? There is no issue. At runtime, you can also switch the selection, right? If you want, you can send long message using SMS sender, and you can also send short message using email sender. At runtime, you need to decide what you need to do. Clear, guys?
Yes.
Right? So this is all about today's session. Tomorrow we are going to discuss.
I have a question, sir.
Yes, ask.
That question related to not this one. That is, I want to ask about the Angular. So
Sorry.
when I read your website, so when we install the Angular, so we have to install ID, Node.js, and all stuff too.
Yes, yeah. So this session is not about Angular. So I'm not going to talk anything related to Angular in this session.
Okay.
Right? So because if I'm going to discuss something related to Angular, then it doesn't make any sense at all at this time, because other people who are there in this meeting, they will feel it is something on unrelated things, right? Angular means it is unrelated, and second thing is that Angular document what I have started before 3 years, and I don't know whether the latest version is supported those things or not,
Okay.
right? So don't ask anything related to Angular. No. See, if something related to C Sharp, then you can ask. Even I'm not
Okay.
going to take the question if the question is related to .NET.
Okay, sir. Thank you.
Any question from anyone else?
No.
No, good question.
Okay. So tomorrow we are having class. Tomorrow we are going to discuss composite design pattern. We are going to discuss proxy design pattern, and we are going to discuss flyweight design pattern. So 3 design patterns are remaining in structural design pattern category. Those design patterns we are trying to cover in tomorrow's session. Right. Thank you guys.